Hello everyone, my name is Rachid Hidki. I am a PhD student at the Laboratory for Fluid Mechanics and Energetics at the Faculty of Science Malali Qadi University. I would like to thank the committee of the Second International Conference on Big Data Modeling and Machine Learning for accepting my paper entitled Effect of the Size and Position of two high generation blocks on natural convection inside a closed cavity. My talk is divided into four main sections. First, a lateral introduction. Second, mathematical formulation and validation. The third one, result and discussion. Finally, we will end with a conclusion. So let's get started with a lateral introduction. The natural convection refers to a situation where a buoyancy difference resulting from a temperature difference in a fluid causes movement of the fluid. The natural convection is the common method used in the electronics cooling. There is a large class of equipment that lends itself to natural convection. The studied configuration is shown in this figure. It is a closed square cavity filled with air and cooled by the single active wall and has on its center two high generation blocks with different sizes. The second part, mathematical formulation. The governing equations are written in the following dimensionless form: the conservation of mass, the momentum equation, and energy equation, where delta is a sample which is 0 in the fluid medium and equal to 1 in the solid medium. The boundary conditions used for the resolution of previous equations are as follows: on all solid walls, on active wall, on the adiabatic walls, on the solid fluid interfaces. The numerical method used in this study is different volume method. So equation 1 to 4 and different boundary conditions are discretized by finite volume method than solved by simple algorithm. Our numerical code has been validated with the experimental result of Parancini and Corvaro, and this figure shows this validation. The principal objectives for this work is to study the effect of block size and their position on streamlines and isotherms. The control parameters are the block size vary from 0.1 to 0.4. The Rayleigh number, conductivity ratio, and Prandtl number are fixed. The third part, result and discussion. This figure shows the streamlines for different block size. For S1 equal S2 equal 0.1, the flow is practically symmetrical with respect to the horizontal median of the cavity. The structure consists of a large clockwise cell encircling block 1 and descending into the space limited by the cold one and block 2. Two low intensity cells appear just below and above block 2, which contribute to its cooling. The observed symmetry disappears as soon as S2 is increased. For the isotherms, this figure shows these lines for different values of S1 and S2. This figure shows that the isotherms are concentrated in the largest block and tight in the fluid medium. The isotherms also show that the maximum temperature increases rapidly with S1 and S2. To study the effect of blocks position, we give in the figure below the streamlines and isotherms for three different positions: bottom, middle, and top. The streamlines show that the position of the blocks significantly affects the structure and intensity of the flow in the cavity. The isotherms show that the bottom and middle position are the best for the good cooling of the both high generation blocks. Finally, we will end with a conclusion. The principal result of this present study is the block size significantly affects the flow and temperature field in the cavity. The isotherms are more concentrated in the largest block. The maximum temperature in the cavity increases rapidly with S1 and S2. The position of bottom or middle should be chosen for good cooling of two studied blocks. And thank you for your attention.